Hello friends, today we are going to discuss about syllabus of engineering thermodynamics as per Gujarat Technological University. So as per the syllabus, as per the teaching scheme you can see there are 4 lectures in a week and 1 laboratory of 2 hours in a week. Total 5 credits are there. If we'll talk about examination scheme, you will observe 70 marks, that is of your end semester examination, 30 marks, that is of your internal test. If we'll talk about the practical marks, then 30 marks, that is your practical viva, that is end semester examination practical viva, and 20 marks, that is your internal weightage, that is of your file or your term work. So grand total is 150 marks. Now we will discuss about course content in detail. So you can see chapter 1 number 1, that is talking about introduction and basic concept. As you know, this is a very important subject. So in the very first chapter you will observe the introduction and basic concepts related to engineering thermodynamics, that include thermodynamic system and control volume, microscopic and macroscopic point of view, thermodynamic properties, state, process, thermodynamic equilibrium, then concept of continuum, quasi-static process, zeroth law of thermodynamic, temperature scale and its application. It will take 4 hours. So within 4 hours we have to complete this part. Now if we'll talk about chapter number 2, you can see there is the first law and second law of thermodynamics. Within 13 lecture we have to complete this syllabus, or within 13 hours we have to complete it. That include very important laws of thermodynamics, which will be helpful to you in a future in the different subjects. So that include first law applicable to the closed system, concept of energy, PMM1, SFE for different devices. Second law, that include the limitation of first law of thermodynamics, Kelvin-Planck statement, Clausius statement, PMM2, applications, in irreversibility, Carnot theorem, corollary of Carnot theorem, thermodynamic temperature scale, etc. Friends, within 14 hours we have to complete chapter number 3, that include the entropy and exergy. So this entropy, that includes the Clausius theorem, property of entropy, definition of entropy, entropy changes in an irreversible process, principle of increase of entropy, exergy of heat input in a cycle, exergy destruction, Gauss-Todala theorem and its application, and second law efficiency. So the detail is given here. So just you can refer the syllabus for chapter number 3. Within 14 hours we try to complete it. Now friends, you can see chapter number 4. Within 23 hours we have to try to complete the chapter. That includes the vapor power cycle, gas power cycle and refrigeration cycle. So that include the Carnot vapor cycle, Rankine cycle, comparison between Carnot and Rankine cycle, calculations. Then we have to discuss different methods to improve the efficiency of Carnot cycle. We have to discuss about gas power cycle. Also we have to discuss in detail about Otto cycle, diesel cycle, dual cycle, its comparison, and Breton cycle. And at the last we have to discuss about refrigeration cycle, that include the simple VCR system, plotting of the VCR system on pH and TS diagram and its analysis. So at later stage you find that the subject power plant engineering, where again in detail we have to discuss about vapor power cycle and gas power cycle. In advanced thermodynamics subject in 6th semester, again you will observe refrigeration system is available. So in detail again we have to discuss that part. The chapter number 5 include the combustion, where we have to discuss about combustion equation, stoichiometric air-fuel ratio, enthalpy of formation, adiabatic flame temperature, determination of calorific value of the fuel, calorimeters, that include the Baum and Junkers calorimeter. Friends, this is a very important chapter. It will be helpful to us throughout our life. and within 6 hours we try to discuss about this combustion part. Now friend, this is related to somewhat your marks, somewhat about the question paper. You can see according to the revised Bloom taxonomy, 20% weightage is given to R level, that is remembrance level. So in exam the question may be there like define entropy, define system, define surrounding, like that. So what is remember to you, that you have to write. 30% weightage is given to understand level, means what you understand from the theory, like what are the application of first law of thermodynamics in real life, what are the application of zeroth law of thermodynamics in real life or in industry application, and most important 50% weightage is given to application part. Means what we learn out of that 50% questions will be asked to you in exam, that is related to application part. Means the numerical that include the steady flow energy equation, numericals for vapor power cycle, numericals for gas power cycle, combustion, first law, second law of thermodynamics. So the application part is given a maximum weightage. So according to the Bloom's taxonomy, 50% weightage is given to application part, 30% weightage is given to understanding part, and 20% weightage is given to remembrance level. Now you can find here some reference books. So you can see here 5 to 6 books were mentioned. You can refer any one book related to engineering thermodynamics. Now the very important thing, what is course outcome. So you can see here course outcomes in terms of CO1 to CO5 is given with the marks percentage weightage is given. So the course outcomes stand for what you will learn from the subject. So CO1 that stand for to identify the unique vocabulary associated with the thermodynamics and explain the basic concept of thermodynamics. Means when you complete the chapter number 1, you are in a position to understand new terms related to engineering thermodynamics, and that term you have to use, or that basic concept you have to use throughout this subject. If we talk about chapter number 2, you can find that to state and apply first law of thermodynamics for closed and open system undergoing the different thermodynamic processes, and evaluate the feasibility of thermodynamic cycle and processes using second law of thermodynamics. Means when you complete the chapter number 2, you are in a position to know what is the first law of thermodynamics and their applications applicable to open system and closed system. What are the application of second law of thermodynamics to different systems. In the same way, when we will discuss about chapter number 4, you will find that to analyze different gas power, vapor power and refrigeration cycle. So when you complete the vapor power cycle, you are in a position to know how to solve the different numerical as well as in which circumstances we have to go with which kind of power plant. CO3 that include to apply the concept of entropy and exergy to the different thermodynamic processes and cycle. So when you complete chapter number 3, you are in a position to understand what is entropy, exergy, energy and all other concept where we have to apply in real life. And at the end, when you complete chapter number 5, you are in a position to make elementary calculation for combustion phenomena. Means when you complete the combustion part, you are in a position to know how to calculate the calorific value of different fuel, how to use bomb calorimeter, junker calorimeter, when we have to use which kind of calorimeter, that also we will understand when we will go with the chapter number 5. This is suggested list of experiment. You find here 11 experiments are shown. So either we have to go for performance or we have to go for study of different experiment according to the systems and setups available at the institute. This is a very important resource for learning. This is open source software, or you can say learning website, that is nptel.ac.in. So here you find the different topics covered by reputed faculties of the country. If you go through this site, definitely you will learn a lot through this learning website. This is a book of engineering thermodynamics which I preferred for subject of engineering thermodynamics. You can refer any book related to engineering thermodynamics, and the main goal is you should gain the knowledge and you should come forward with this subject. Thank you.